Hello everyone, welcome back. Today we're going to use some very important formula to prove perpendicular vectors and also parallel vectors. So we're going to revise 3 rules first. Before I do this question, which is Q 2022 HEC Math Extension 1 External Exam paper. Question 13 actually is, or question 14, sorry, question 14B. So we've got a formula to revise. First, I want to revise is, now this is tilted means vector. Vector A, magnitude of the A square is the dot product of the vector itself. So that's first one. Second one is, if I have a vector A perpendicular to vector B, that can give us direction, give us the conclusion is dot product between the two is 0. So that's a very important formula we're going to use. So question says we have a U, vector U, are not parallel to vector V. So we've got 2 vectors. Oh, just remind everyone to subscribe to this channel if you haven't do so, because of this channel grow to very a lot of videos, 170 plus. So you don't want to miss any latest update. So you can support this channel grow, continue grow to subscribe it. Thank you for that. So these are the 2 vectors. They are not parallel, but the P, vector P, so we've got another vector here, is the projection, vector projection from U onto V. So that means projection means you have to be right angle. So that's a perpendicular. So we say because of the projection onto the vector V, so we can say P is the scalar. So we call lambda 0 times by vector V. So this vector P must be parallel. So because vector P must be parallel to vector V. So there's a third one. So if I have A parallel to B, so that means A can be written as a scalar quantity times by B. Or we can write a B is a scalar quantity. We can call it K0 A. So that's that's 3 very important concept of a vector perpendicular, parallel, and also the square. So we can say this is the Greek letter lambda. So so therefore we need to prove. What are we going to prove? This length of 0 is the smallest real number. So prove that if I put another variable called lambda, so that means the smallest is when the length equal to length of 0. So you need to prove. So that means if I put a variable length is always greater than the length of 0. So that length of 0 must be your smallest. So that's the key. I'm going to prove. All right, how do we do that? Well, let's solve that. First of all, we need to prove I'm going to draw the triangle. So what I'll do is I'm going to let length belongs to real set. That's real number. So what I'll do is I'm going to prove this one always great. So what we're going to prove is we are aiming for u vector u length of v vector always greater than u vector u length of 0, which is the p vector. So always that's the case. So we need a magnitude of magnitude. So that means that's the smallest length. All right, so what I'll do, I'm going to put a square first. I'll choose the magnitude of those two. So this is the vector we are going to, so we call u, take away length of v. So length can be varied. Now what I'll do is, according to the graph, if you look at the, I call p is a length of 0. So therefore that's a vertical is a length, u take away length of 0, which is p. So that's a p. All right, so what I'll do, I'm going to minus that plus that. So I'm going to put these two together as a, so that's the vector of the vertical. So that's a length of 0. So that's the one I want to use it. And then you put these two together. I'll take a v out. So that's the first step. Then I'm going to use this formula. I'm going to highlight again. This is the formula I'm going to use. Because that's a absolute two vectors square, magnitude of square, I'm going to use the dot product of the two. So I'm going to write like a absolute value square equal to vector A dot vector A. So this is the formula I'm using. So I'll put a dot product between the two vectors. Then I expand in the brackets because those are all dot product. I can use a distribution law. So I'm going to distribute, expanding the brackets. So a stew vector can do that. So the first one, because the two vectors dot together, becomes square again. Magnitude of square, then those in the middle, those two are the same. This is the same. Those two are the same. And last one is the squared again. Expanding the bracket. Now, can you see those two vectors? That vector is perpendicular to that vector. Can you realize? Because that's the scalar quantity of the vector v. And that's the vector is the perpendicular to v. So therefore, this is very important. So these two vectors are perpendicular. So therefore, their dot product must be equal to 0. So therefore, these middle two terms become zeros. So I end up the left-hand side equal to only two square terms. Now, then we're going to decide, we're going to prove the reason we're going to prove that. So therefore, we need to decide this particular term, highlighting this, is greater than 0 because it's a square term. So therefore, this must be greater than this because that's more than 0. So then I'll undo the square root both sides. So therefore, I've proved u minus length of v always greater or equal than u vector minus length of 0v. So therefore, that must be the smallest value of length. That's it. I prove that using those three rules, perpendicular, parallel, and also the magnitude square dot product. A bit messy, but if you like the video, please give us the thumbs up. I will see you next video. Thank you for watching.